Hello, everyone, and welcome to Strawberry Chat. This is a monthly event where we talk about relevant topics and address any pre-submitted questions in the world of strawberry production. My name is Miranda Purcell, and I'm the Viticulture Extension Specialist at Purdue University, located here on campus. And this event is co-hosted by Dr. Wenjing Guan. Just a reminder that this event is being recorded and we will turn the recording into a podcast, and so it will be available to listen to at a later date. If you're on the email list to receive updates about the event, you will also receive an email when the podcast is up and ready to go. And with that, I will hand it over to Dr. Wenjing Guan.
Hello, everyone. My name is Wenjing. I'm the horticulture specialist located at Southwest Purdue Agriculture Center in Vincennes, Indiana. Our topic today is about high tunnel strawberry production. We will share what we have learned over the years in growing strawberries in high tunnels at our research farm in southern Indiana, and what we have learned by working with farmers who are currently exploring the system. Today, we have Dr. Laura Ingwell and Dr. Dan Egel joining our discussion.
My name is Laura Ingwell. I am an extension specialist in the Department of Entomology. I'm located on the main campus in West Lafayette, and I work specifically on insect pest management in specialty crop production systems. I'm most interested in looking at protected environments, so I've been working with Wenjing and high tunnel production with strawberries and some other crops for the last few years.
I'm Dan Egel. I'm an extension specialist in plant pathology for Purdue University. I'm located in Vincennes, right down the hall from where Wenjing is. So I'm not on campus, but I have statewide responsibilities. My responsibilities are primarily for vegetables and vegetable diseases, and so that's what I do. But ever since Wenjing has gotten involved in strawberry production, I've gotten involved in management of strawberry diseases and also high tunnel production.
A previous strawberry chat, we discussed the plastic culture strawberry production. A limitation of using the annual plastic culture system in Indiana is potentially low yield. The low yield is due to a lack of growth in the fall at the plant crown. We know the flower clusters are formed inside the crown. Crown growth directly related to yield potential in the next spring, and crown grow at temperatures above 15 Fahrenheit. Because temperatures may drop fast in the fall, depending on the year and the planting date, crop may not have enough growth before winter arrived. To overcome these challenges, it's natural to consider using some sort of protection to increase growing degree days in the fall. Farmers use tools ranging from floating row covers to various types of tunnels for this purpose. Our discussion today focused on using high tunnels. Obviously, it's a semi-permanent structure. Comparing growing short day type strawberries in open field with the plastic culture system, there are several advantages of growing short day strawberries in high tunnels with plastic culture. In terms of those advantages, first, high tunnel structure increase growing degree days in the fall, so there's a higher chance that the crops could achieve a good yield in the following spring. Secondly, high tunnel provides protection for spring frosts. This would largely reduce the risk of flower loss due to late spring frost damage. Certainly, high tunnel block natural rainfall, so risks for several foliar diseases, including botrytis furage and anthracnose, might be reduced. So the extended early season harvest is another advantage. In southern Indiana, we found it's possible to start harvesting short day type strawberries in middle April. which is about 3 to 4 weeks earlier compared to harvesting open field plastic culture strawberries, and about 5 to 6 weeks earlier compared to harvesting strawberry growing on a matted row system in our region. Not only the earlier harvest inside the high tunnel strawberry tend to have a longer harvest period and a higher yield compared to that of open field grown strawberries. So those are the potential advantages of high tunnel Juneberry strawberry production. Two questions I often hear farmers ask about this system. The first question, often from experience of strawberry growers, the question is whether growing strawberry in the high tunnel meets the crop's chilling requirement. I think this is a very good question. Typically, we consider temperatures between 28 to 14.5 Fahrenheit in this range are effective towards the chilling requirement. And the cultivars vary in chilling hours. Meet the chilling requirement ensures the plant would have enough vegetative growth to support the development of flowers into high quality fruit in the spring. That's why we are concerned about the chilling hours. We have found in most of the days in the winter, with using floating row covers in high tunnel in southern Indiana, the average air temperature and plant canopy were between 14 to 15 Fahrenheit. A few days it may drop to 30s. Very interesting we find is the cultivars that are adapted to warmer climate with lower chilling requirement tend to have the greatest yield in the high tunnel system, while cultivars typically adapted to grow in the northern area tend to have a lower yield in the high tunnel system. So what our research find, this showed a great example demonstrating the importance of selecting strawberry cultivars to target specific location and the production systems. Another question I hear people ask about the high tunnel system is whether it's economically feasible to grow strawberry in high tunnels. Considering the per square foot yield of strawberries certainly is not as high as like farmers growing tomatoes or cucumbers in the high tunnel. Well, I think the answer to this question would depend on your specific situation. Here is a few scenarios I think farmers may find the high tunnel system attractive. In the first scenario, one may currently grow strawberry in an open field and wants to extend the strawberry season with a relatively lower input. We know it's possible to take advantage of government funds to build high tunnels, the NRC's EQUIP program. And even more affordable, farmers can use caterpillar tunnels. The per square foot cost is even lower than high tunnel. And those structures work perfectly for crops like strawberry because they don't need the trellis system. And the extended strawberry season might bring farmers a market advantage. So the benefit is more than just the value of the crop itself. And in a second scenario, one may already have multiple high tunnels and may be interested in diversifying their crop inside high tunnels. They have enough tomatoes, so they want to diversify the crops to meet the market need. In this case, strawberry may be a rotational crop. This is why I think so. Because strawberry season starts from early September and ends in early June the following year. So technically, before September, at the time when strawberry are planted, there's enough time to grow tomato or cucumbers in the same high tunnel. And after the strawberry harvest end in early June, there's still time to grow tomatoes or cucumbers from June to the first of frost. So some folks maybe are interested in know exactly what yield they might expect with growing strawberry in the tunnels. So I want to share some of the numbers we have. In terms of the yield at our research farm with sandy known soil, we found most cultivars, like we are doing variety trials in our system. We found most cultivars can yield above 1.5 pounds per plant, using a spacing that can accommodate about 1,000 plants in a 13 by 96 high tunnel. And in a few cultivars that are really doing well, like the Florida cultivar Radiance and a few other cultivars, we can achieve about 2 pounds per plant. So you could do the math, and that could give you an idea of the yield in one high tunnel. And I have been hear farmers tell me they could sell their strawberries considering towards the end of April, early May. At that time, it's easy to sell strawberry at a premium price. I also hear farmers tell me with the addition of strawberry in their market is more likely to attract people come to their farm stand to buy other crops. So back to the question earlier, whether it's economically feasible to grow strawberry in high tunnels, I really feel there's not a yes or no answer. Very much would depend on individual specific situation and market strategies. So the above story I described, I know it could be quite exciting. We are excited when we saw those yield. However, very quickly, we realized success of our stories cannot always be duplicated in growers' high tunnels. I will explain why. We think the key factor here is the type of soil and the soil condition. So strawberries really like very well-drained soils, but this is not always possible. Many urban and smaller scale farmers are working with heavier soils. And after growing tomato and other crops in the high tunnel for years, we noticed the soil tend to have high pH, and in some cases, it has extremely high levels of certain nutrient, depending on which amendment have been added to the soil. Unfortunately, strawberry is probably one of the crops that are most sensitive to high pH and high salts. So what we have found is strawberry growing inside of those high tunnels might have stunted growth and yield poorly. Another potential challenge of the in-ground high tunnel production system is the buildup of soil-borne diseases, especially if strawberries are followed with other high-value crops. So here I want to ask Dan to comment on this situation. Dan, do you think any specific soil-borne diseases farmers should watch for?
Well, Wenjing warned me that she was going to ask this question, so I kind of studied up on it. So I'll mention a few diseases that I have seen or read about that might be consistent between tomato and strawberry. But the real question is, I think, if you grow tomato and strawberry, are you going to make any of these diseases worse in either or both crops? So one disease that Wenjing and I have seen in both crops is white mold. So white mold, and I guess we don't have photos here, but white mold is true to its name. It looks like a white mold, and it can cause the death of both strawberry and tomato plants. But you'll see dark fungal bodies. Looks like what I call rat turds, kind of irregular bodies, fungal bodies. So white mold can be in both in tomatoes and strawberries, but white mold, the biology of it is such that it's in mushrooms that can be 300 feet from the tunnel, so it can come in from outside. So really, whether you rotate or not, white mold could become an issue. Also, white mold has a huge host range. So for that reason, I'm not sure you can get away from white mold with most rotation. Sanitation between crops and landscape cloth, as Wenjing has talked about, are two of the things that I think are important for white mold. Anthracnose is another disease that Wenjing and I have seen both in strawberries and tomatoes, but it's a bigger disease outside the high tunnel in the field than it is in a high tunnel where you have you don't have as much leaf wetness, you don't have as much moisture. There's different species that cause anthracnose on tomato, and there's different species that cause anthracnose on strawberry, and there's one species in common between the two of them. And so I don't remember the species name, but there is one anthracnose species that is listed both on tomato and on strawberry. So I don't think it's a huge issue in a high tunnel, but it is a potential overlap. But you wouldn't, anthracnose on a high tunnel, you wouldn't see so much leaf problems. You wouldn't see fruit problems, which we've seen in a high tunnel, but you might see anthracnose. We've seen anthracnose as a crown problem. So it's possible you could see anthracnose on the crown of a strawberry plant, and then it could overwinter and be an issue on tomatoes. That's a potential issue. Gray mold is, or sometimes called botrytis gray mold, is a problem on tomatoes. It's a problem on tomato or strawberries, and it again has a huge host range. So again, rotating is not maybe not a real good way to get away from that. But I know that we have seen gray mold on tomatoes in commercial greenhouses. We've seen gray mold on our strawberries or your strawberries down there. So that is a potential problem. But again, gray mold has a huge host range. In reading up on, I've not seen this in strawberries, but verticillium wilt is listed for tomatoes and strawberry. All right, so that would be a potential disease that's in common to those two. But it's a soil-borne disease. It's in the soil. But it would be something to watch out for. But I know there's host resistance for tomato for verticillium wilt, and I've read that there's host resistance in some strawberry cultivars as well. So that would be a way to manage that. And then there's just a host of other soil-borne diseases: Pythium, Rhizoctonia, different fusariums, not fusarium wilt, but just different soil-borne fusariums that could cause problems on strawberry and tomato. However, again, those have huge host ranges. And then, Wenjing, you and I have seen root knot nematode. And I don't know, I've seen it in strawberries, but I know it can happen on strawberries, and we've certainly seen it on tomatoes. And if you didn't watch it, that problem could be getting worse on both crops, and unless you dig the plant up, you wouldn't see the symptoms and know that's what's causing the problem. You and I have gone in tomato greenhouses, for example, and seen the grower will complain about the plant is declining, but unless you dig that up, you don't know. So that root knot nematodes and other nematodes would be another disease to watch for.
I think in terms of nematode, I know mission nematode cause damage on the strawberries. But in general, as we are doing the rotation, if we keep the high tunnel warm, keep the soil temperatures warm, nematode could become an issue build up in the structure.
There's other questions people they can have questions about that, or have other problems that they've noticed, they can let us know.
I described earlier the season of growing strawberries, and summertime is the off season actually for this production system. Technically, a few months in the summer could be a window to incorporate soil disinfection strategies if farmers do not continue crop. So summer could be a window to incorporate those strategies. That might help prevent buildup of soil-borne disease. Dan, could you tell us some of the options small-scale farmers may consider, and what's your opinion on those strategies?
Let's talk about what soil solarization is, and also uh, some of the limitations, I guess. So in the U.S., well, and around the world, really, soil solarization is usually used in places with a lot of sunshine. So, for example, the Southwest U.S., for example, and they would, of course, in the Southwest, that's an off season for them. They're not usually growing. They're growing, and they're not growing in the summer, so they can do soil solarization when the sun is hottest, when the days are longest. So that's when, if solarization is used, that's usually the time period. But for us, you were saying what strawberries are probably would be out of the tunnel in June.
Yes, we end harvesting early June because that's too hot to have a good quality strawberry.
So if you were to take the strawberries out then, and you didn't want to put another crop in, that's, you could go from sometime in June, and that's when you could do soil solarization. So let's talk about what soil solarization is. So in general, what you're doing is you're putting plastic on the soil, and you're putting clear plastic, and then the sun goes in the plastic. It's transmitted through the plastic. It heats the soil up, and then it's a greenhouse effect in the soil. And when you're doing it in a high tunnel, you're talking about a greenhouse within a greenhouse, right? Because if you shut up that high tunnel, it's going to get hot, and then the sun's rays will also go into the plastic in the soil and heat that up. So you have a potential to heat the soil to be hot enough that will kill uh, pathogens, or many of the pathogens. And research that's been done indicates that in general, you're not getting rid of the beneficials, you're just getting rid of the pathogens. So that's a good thing. So, but in order to do this, there's a lot to it. One of the things that occurs to me in our greenhouses, Wenjing, we have a lot of equipment in there, and I don't know what would be the effect of closing that up and making that hot for the duration. I don't know. You'd have to check on the equipment. Um, but you'd want the soil to be well tilled and free of crop debris. So you don't want to just take the strawberries out without tilling it and getting rid of any kind of crop debris. Again, landscape cloth will help that, help keep the soil free of plant debris. You want to thoroughly wet the soil to 12 inches. So you'd have to put sprinklers in there after the soil was tilled, thoroughly wet it to 12 inches, because the heat will transmit better in that in that wet soil. And then you'd want to use clear polyethylene. And in some cases, when I talk about this to people, they'll assume that black plastic is better, but it's actually clear plastic. And really, the thinner, the better. The only disadvantage of using a real thin plastic is that it might scuff, or if you walk over, it'll break. But really, the thinner you can get away with, the better, anywhere from 0.5 to 4 mils. And then really, you want to keep it this way from 4 to 6 weeks. So if you're talking from mid-June, you can go all the way through July, and that would probably be warm enough or long enough. I would recommend a soil thermometer, something you can get to. And I read different temperatures, but at one place I read that in the top 6 inches, you want it to get 140 degrees Fahrenheit. Okay. Someplace else I read the temperatures might range from a high of 126 Fahrenheit at 1 inches to 98 Fahrenheit at 12 inches. And there's much more detail. I'd be glad to, if someone was to contact me about this, but the details are important. The other thing is, Sally Miller, Ohio State, and other people have done some work on anaerobic soil disinfestation, and that would involve similar steps. But in that case, what you're doing is taking a source of organic matter, molasses or something like that, incorporating it into the soil, and it's the decomposition of that which helps get rid of the pathogens. And Sally Miller of Ohio State has some very good data on that. So that might be another way you would consider that.
Okay. Thanks, Dan, for all the detailed information. Yes, there's a lot of things involved in those strategies. So if farmers using that, paying attention to the details, it's really important to ensure those strategies would work. We discussed earlier that the system might reduce some foliar disease pressures, but not for insects pests. One of the major challenges we have encountered in this system is two-spotted spider mites. We saw the spider mites in the fall, and in severe cases, entire plants could decline even before harvest, cause dramatic damage. And another pest that we encountered is aphids. Some years we saw very high population of aphids in the winter. So at this point, I want to turn to Laura. And Laura, could you help us better understand those pests and where they come from, their life cycle, their preferred environment? I know there's a lot. Yeah, thanks, Laura.
Yeah, there are a lot of pests, but broadly we'll talk about the two groups, right? So two-spotted spider mites and aphids in general. These are both very well studied insect pests, and we know a bit about their overwintering habitats or lifestyles. And what we can gain from the literature and our own experiences, I think, is that for both of these situations, they are likely hunkering down and overwintering in the tunnels with our crops. So two-spotted spider mites in general, in outdoor environments, reproductive females are the ones that will overwinter in this sort of resting state. So they will mate with a male in fall, and then they're ready to go and lay eggs in the summer, but they'll go through this diapause resting state and they'll bury down in the soil and they'll just hang out there until it gets warm. But what we've learned about them is that they can very quickly become acclimated to cooler temperatures. And if there are resources available, and if those temperature extremes are buffered, we would expect that they're overwintering on the crop and not necessarily going into that resting diapause, but they may actually continue to feed. And if the environmental conditions are right, they could also be reproducing. And so they can survive as low as -4 Fahrenheit. And the later that happens in the winter, the more they have become used to that cooling temperature. They very quickly acclimate. And so, yes, they're overwintering on the crop themselves. How do they get on the strawberry in the first place? Well, spider mites are wind dispersed. And they also have a very, very large host range, a lot like some of the diseases Dan was mentioning. So if you were growing cucumbers or tomatoes in the summer, and you notice a spider mite population on those plants, when you clean out the high tunnel and put the new crop in, it's very likely that they can be hanging out on the structure, in any lingering weeds, or in the vegetation around the outside of the tunnel, and then they can crawl their way back in. So just being diligent of that and being proactive in terms of managing if you anticipate that they could colonize those early plantings in fall when you put the strawberry into the tunnel. So we see a similar situation with aphids. I think we know less about this pest. So a lot of the aphids that we experience in our cropping systems have two different sort of modes of biology and overwintering strategies, reproductive strategies. One of them is where they are what we call a holocyclic population. So they'll actually develop males in the fall. Normally they're all clonal females in summer. They'll develop males in the fall and females with wings, and they will fly off to an alternative host, often a woody plant, and they'll mate and lay eggs. We really don't have a good understanding of where these eggs can be found and what proportion of the population does this. But then those eggs are in a resting state until spring, and when the eggs hatch, winged individuals will come out and then move back on to the annual crops that they can feed on. The alternative is that they remain parthogenic or anholocyclic. They can remain all females and continue to survive throughout the winter, feeding, slowing down their feeding, slowing down their reproduction, but feeding on the host. And we can see even under snowpack, if the host plant is alive, they can handle those temperatures and they can stay and feed. Non-winged individuals walk from plant to plant, but again, if the plant quality declines or they become overcrowded, they can create winged individuals, which can travel very far distances. So it's that winged morph that's likely moving in and out of the tunnel and colonizing the crop. The species of aphids that we see is really variable. I think most often down at swaypack on your strawberries, we have found what we call the potato or the tomato aphid, Macrocyphum euphorbiae. Up here in West Lafayette and Lafayette, we often see the melon aphid or the cotton aphid, Aphis scicipii. Very similar, just a little bit different in size. In the strawberry system, we're not so much worried about any diseases. They don't transmit diseases in our area. It's more the overwhelming nature of really high populations. And then the honeydew that they secrete on the plant, which then grows this sooty mold. So you get this black layer on the leaves, which blocks photosynthesis and really can lead to plant decline.
Laura, you mentioned the two types of aphids. Is that important for farmers to tell which is which, or really
no,
similar?
No, and you wouldn't be able to tell by looking at them. They look the same. Basically, what farmers need to know is that likely you have this female clonal version that you experience in summer also just hanging around in the winter.
So those two aphids you mentioned, is there a host range? Would that overlap with tomatoes or other crops that they would be likely growing?
Yes. The names are very deceiving. They both feed on hundreds of different plants. So they'll overlap from crops, but they can also just use weeds as an overlapping host as well if there's a break in the crop cycle.
I know many high tunnel farmers are interested in using beneficial insects to control those pests. Again, there's a lot of knowledge involved in selecting the type of beneficials and how to release them, how to make sure they work. So, Laura, could you give our audience some advice to increase their success in using biological control approach? What are the limitations of using this strategy in high tunnel?
I can try. So this is an area of research that we're spending a lot of time in right now because we really don't know how well natural enemies perform in a high tunnel. It's this really, unique environment between a greenhouse and a field condition. I think when we're talking about strawberry production and specifically managing these pests in the fall and early spring, we're closer to a greenhouse setting. So what that means for growers is dispersal may be a little less likely than it is if you're trying to incorporate a beneficial in summer in the high tunnels when a lot of the ventilation is open. But really so the two things that you really need to consider is this dispersal capability. How do you keep that natural enemy happy on your crop so that they don't move off and move elsewhere? And then the other thing that's really important is understanding the environmental conditions. Because just like the pests themselves, the natural enemies have ideal conditions under which they're actually trying to reproduce and are actively foraging and feeding on the pest. A lot of these are native species, and they also are adapted to go into some degree of hibernation or resting state in winter. And so you don't want to be using an insect. You could buy them still and put them in your high tunnel, but if your day length is too short, they're not going to feed. And so it's understanding those biological limitations, which hopefully I can help with because we can pull some of that from the literature. And so first thinking about dispersal, right? Selecting your agent can make a difference there. So if you select something like a lady beetle or an adult lacewing, for instance, they have very well-developed wings. They can travel great distances. They're a little harder to contain. When given the option, if you can purchase the larval form of those insects, then they are restricted just to crawling. So they're more likely to find food as they're crawling around than to just open their wings up and fly away immediately, right? So in general, I don't ever recommend purchasing adult lady beetles. They just fly away in the wind and don't do much. But if you have access to the larval species, the immatures of the species, so Adalia bipunctata, the two-spotted lady beetle, is one that you can purchase that are reared from commercial suppliers. And so you can get eggs or the larval stages that cannot fly away. So the larval lady beetles are a good option for aphids. Larval lacewings can be a good option too, but you have to be careful with the temperature. And we don't have a really good understanding, but anything sort of below 50, I think, and you're getting a little too cold for that larva to actually survive and be foraging. Aureus insidiosus is another species that can feed on mites and thrips and sometimes aphids. They become very, very abundant in the fall in Indiana, so you'll see them flying around. They're a true bug, so they have a little beak mouth part that they use to stab their prey, but they'll also stab your arm in fall if you're really if you're outside a lot. They're one that go into this program diapause that you cannot change, and it's related to day length. So once we get into the short days of winter, they will stop feeding and they wait until day length increases again. So if you're growing in a high tunnel where you're not extending the day with artificial lights, don't try to use that species. I'm not really sure that we have good information about parasitoids and how well parasitoids perform in colder weather. In spring, when it starts to warm up, and if you don't have low tunnels on the crop and they can actually fly around, parasitoids may be a good investment, but that's one that we're going to be looking at with some of the research we're doing currently in high tunnels to see how well parasitoids can do in the wintertime. And then if we move on and talk more about spider mites and spider mite management, predatory mite species are the best way to go in that situation. And there you can get very quickly overwhelmed by the number of predatory mite species that are available. And so there's a few things in particular to note. The two-spotted spider mite specialist, Phytocoeus persimilis, is a species that is oftentimes recommended and can be very successful in greenhouse situations. And they're one that you would want to use if you know you have a population present and it's sort of a reactive type of measure. If you don't have a high number of spider mites available, though, they will have no food and they will disappear very, very quickly. So they're good at knocking back the population. But again, their ideal temperatures are closer to 70 degrees. So we don't really know how well they would perform under these low tunnels and under these cooler temperatures. Then there's a subset of what we would consider more generalist predatory mites, meaning if two-spotted spider mite isn't available, they may feed on other mite species, soil-dwelling mites or other plant-feeding mites that aren't as numerous or problematic. They also may feed a little bit on the plant to tide themselves over, or if there's any pollen resources available from weeds or the crop itself. And so they can colonize and are usually present longer if prey is scarce. And so there is something that could be more of a maintenance that you could put out when you transplant as sort of a prevention and to keep that population in check. And when you're looking at these, they all have different sort of ideal temperatures and relative humidity for their performance. And so you can find this information online from suppliers like Arbeco Organics or Copert or BioBest. They can tell you. But some of the more colder tolerant species are Amblysius andersonii, or Noceus californicus. And one that we find present and naturally occurring is Noceus phallacis. And so those are ones that you could put out in your tunnels and expect some level of colonization and retention and sort of maintaining those low populations. And then if you see hot spots or outbursts, you could add Persimolis. But again, we're doing more work this winter to really look at how well they can perform in an Indiana winter on strawberries. But yeah, those are the ones that I would recommend to start with. And regardless of what you use, make sure that you go back. The predators themselves can be very difficult to find, especially if you're talking about predatory mites, right? But a lot of them sometimes will hide during the day and forage at night. So the best thing you can do to be able to evaluate if the predators are actually effective is flag a population, flag a leaf or a plant in particular where you see that pest, and then go back to that flagged spot and see, is that population spreading and growing? Is it staying the same, or are you seeing a reduction? And that way you'll know if it was worth the money to release them and if it's something you should do again. And it can also give you an idea of how long they're controlling, right? So if you mark that spot, so you go back to the exact same place every time you're out there and sort of use that as your indicator, that's the best way that a grower can evaluate it, rather than trying to track down what you actually put out and see if you can capture them again. That's very difficult.
Yeah, thanks, Laura. That's really great advice, and a lot of situation are described. Make me feel I really need to go back to look at the strategies I used, and it probably really gave me the reason why I didn't see them work earlier. Yeah, so those are great information. And then Laura, next question I want to ask you is, what's your opinion on, there are many organic pesticide options in the market. What's your opinion on their efficacy and how you think about best way to use them?
Yeah, there are a lot, like more than I could ever list. So I've been spending some time looking at some of the newer organic pesticides, and a lot of those are biological organisms. So things like soil-borne bacterium that we have identified and have insecticidal properties, and putting that on the plant. And so these are things like Venerate product from Marone or Grandivo product from Marone, two different soil-borne bacteria, and then also some fungal species. This is Bavaria bassiana. It's often the trade name Mycotrol is one that growers I know have used and tried. And so I'm excited about them, but so far I have not had a lot of luck with their efficacy against mites or aphids, with the caveat that when you're using them in summer, the biggest challenge is light breakdown. So the sun itself will degrade the product on the plant, or the extreme temperatures and dryness. Especially for something like Mycotrol, which is a fungal pathogen, you need humidity and moisture for that fungus to perform and infect the insect host. And you need cooler temperatures. And so I'm very excited to work with these this winter and see how they perform. I think that Mycotrol is one that is probably the most promising of the biological organic pesticides that could work really well in the conditions for strawberries in winter under low tunnels and in high tunnels, where you may have just enough leaf moisture and high enough density of planting for it to be effective. But again, we have to watch how cold that temperature gets and if that fungus is still viable. Some of the other options that growers use a lot are things like soaps and oils and neem products. And so, again, you don't have to worry too much about the burning that you can get from those products in summer because of the sunlight on the plant when you're in the high tunnel. those are contact insecticides. So you have to make sure, if you think about the dense canopy of a strawberry plant and where we find those aphid populations and those mite populations, which is on the undersides of those leaves, application can be very difficult to actually physically cover the pest populations on the undersides of the leaves on those plastic rows. And so that's where making sure that the droplet size is as small as you can get it. And if you're using a wand on your applicator, that you can turn that wand upside down and actually tuck it in the plant canopy and spray from the undersides to get it on those. And look at the product. If there's a sticker or a spreader that you can mix in with that, that can really help increase the coverage so that you're getting the most out of those products.
Last, Laura, I want to ask you about your synthetic pesticide recommendations for the two pests. And should folks worry about the pest developing resistance to those chemicals?
Yeah, so the one thing to keep in mind, again, in general, their reproduction is going to be slower in the colder temperatures, but both of these populations, both of these pests, mites and aphids, reproduce very quickly, and you'll have multiple generations. And so under that situation, you really want to be careful about resistance development. And so the best rule of thumb is never apply the same compound or IRAC compound. So that's the Insecticide Resistance Action Committee. They give a number to each product so you know the mode of action or the way in which that product kills the targeted pest. You never want to do more than 2 applications in a row of the same code, that same IRAC code. Then you want to switch it up so that you're less likely to develop resistance. And you can switch to a new code for 2 applications and then go back again to that one. But you want to make sure you're taking a break in there. And so one of the other things that you had mentioned, I think, was about how well they work with natural enemies, and whether you're using biological control or not relying on it, you still want to keep in mind that there are natural enemies that are going to be present in that crop. And as the crop gets older, there are going to be pollinators in there that you want to minimize the impacts. And so choosing a product that is specific to the pest is the best strategy that you can do. One that we have had really good success with for managing aphids is the active ingredient flonicoimid. This is under the trade name bee leaf. It targets just piercing, sucking insects. And so you don't have those non-target impacts on your beneficial organisms like parasitoids or lady beetles or lacewings. And so that's a really good one for aphid populations. And oftentimes I find that one application of that will really, really knock that population back. It takes a little time for them to die, so don't expect to go in 12 hours later and see them dead, but a day, 2 days, you'll see them start to desiccate and dry up on the leaves, and then they will die. If you're looking at miticides, acromite is one that if you go on, so a lot of our biological suppliers create what they call side effects databases. So you can go online from Copert or BioBest, and you can look up the beneficial organisms of the lady beetle or the predatory mite that you're interested in and put in some of these insecticides, both organic and conventional, and see what the risk is. And bifenthate, which is acromite, is one that is pretty safe for beneficials. There's a very, very low risk. If you were to compare that to something like a sale or abamectin, Agrimec, those are going to have much more negative effects on that beneficial community.
At this time, I want to take advantage to ask Dan another question. It's about powder mildew. This disease seems to be more of a problem in high tunnel compared to open field. Dan, can you help us understand why is it and what are the control strategies?
Well, powdery mildew Of course, there's different. First of all, there are different powdery mildews on different crops. So the one that you see on tomatoes, for example, is not the same species as you see on strawberries. But regardless, when you put a tunnel over something, you put a covering over something. In general, you have higher humidity, and so there are certain diseases. Two things: you get higher humidity in there, and you don't get as much leaf wetness. So diseases like powdery mildew need high humidity, but don't need leaf wetness. The same is true for gray mold and white mold, for example. So that's why you see those diseases predominate in high tunnels. So it's the high humidity that's what's driving that. I don't know if you asked me this, but in general, I don't know as much about powdery mildew in strawberries as I do on other crops. But in general, if you're talking about synthetic products, I recommend for powdery mildew a systemic, one that goes into the plant and can affect both sides of the leaf. So for example, you apply it on the top of the leaf, it goes to both sides because you can get colonies of powdery mildew on both sides of the leaf. And then with strawberries, and we've seen this, Wenjing, with strawberries as with many other crops, there is some host resistance. So if you do recognize that you have problems with powdery mildew, then you might want to think about varieties which are at least less susceptible.
Yes, we definitely see the difference on varieties susceptibility towards this pest, and that is another indication of the importance of selecting the cultivars suitable for growing in the high tunnel situation. At this time, I want to talk very briefly of some of the research we are currently doing. As we mentioned earlier, soil condition is a limitation for the high tunnel production system. And we are collaborating with colleagues at Ohio State University and Tanglewood Berry Farm in Fort Wayne, Indiana, and we are currently exploring substrate production for the June-bearing type cultivars and targeting spring harvest. We know most of the research for the substrate production was for the neutral cultivars. Whether this high tunnel system with June-bearing cultivars with a substrate production system would be economic feasible, that is what we want to find out. And that can help the folks if they do not have a good quality soil, if they can economically feasible of using a substrate production system. And in addition, Laura Ingwell and her team are currently doing research, as Laura explained, to understanding for the pest management in the high tunnel condition on strawberries and several other crops. Lastly, I want to acknowledge the funding sources of the strawberry research we are doing at Purdue. The initial strawberry research was supported by a Purdue Ag Seed grant, and now North Central SARE research and education grant is supporting us in exploring the different production systems to grow strawberries at small diversified farms. And a specialty crops research initiative grant led by Laura is supporting our research in high tunnel pest management.
Thanks, everyone. Thank you, Laura, and thank you, Dan, for joining us today. We are wrapping up the Strawberry Chats for this year. And so if you've tuned in today or during any of our other sessions, we'd love if you take just a moment to fill out a survey and give us some feedback on what we can do better.
Thank you, everyone. Thanks, Dan, Laura, participate our chat today.
Thank you.
Thank you.